Alright, so now we've seen how deep networks can be subject to vanishing gradient and exploding gradient. So that prevented us from going very deep in terms of deep learning. Now ResNet came in 2015, developed by He et al. And has 152 layers, which is very deep compared to all the other networks that were available at that time. So it basically won the ImageNet competition and was a mile ahead of everybody else. Yeah, so quite a performance here. And they showed that going deep was not a real issue here, and we will shortly explain why that is. So remember, we have our color picture of our cat and dog, and this is again 150 pixels times 150 pixels times 3 channels for R, G and B, color image. And then we have our convolutional layers. We have a CovNet layer, we have a ReLU for nonlinearity, and we have a pooling layer. Here we have the same, CovNet 2, ReLU pool. Here again, CovNet 3, ReLU pool. Now, what ResNet is going to do, well, it's going to tap on the signal here, and it will actually inject the signal just before we apply the ReLU. So you skip a connection, and that's why this is called skip connection. And so this whole piece here we call a residual block. And if we stack a number of residual blocks together, we have a ResNet. So I've shown this here. So here we have a stack of 5 residual blocks together, and it works quite well. So here I've shown the graph of the number of layers and the training error. Theory says that the more layers you have, the lower your error, your training error is going to be. So that's the black line is the theory. In reality, of course, because we have issues dealing with vanishing and exploding gradient, this will go like this, which gives you a problem because you can't go beyond that number of layers, the number of layers you have here. However, when we use ResNets, we get the green curve here. So you see that the training error is still going down. Now, why do ResNets work well? Well, we're going to show this here. We have an input, we have a deep neural network, and here we stop. Here we have A3, and here as well we have A3, right? So here I'm going to call this W3. Here at the end we have a 4 and W4, and here we have a 5. So what's going to happen here is that the output here, so we're going to have A5 equal to, and remember we inject here before we apply the ReLU. So we're going to have ReLU, and then we're going to have A4W4 plus B4, the bias. And here we're going to inject A3 as well. So plus A3. And then we take the ReLU. Alright? Now what we know is that if you remember how we can do weight decay, regularization, remember we had this circle here, like this. So you want the solution to be in this circle. Now remember we had here our contour plots, and basically your result will be on this red line. And this smaller area you control by a factor lambda. So you have your you have your cost, and then you're gonna add lambda, and in the case of rich, you're gonna go lambda and the level 2 norm of that vector squared. Yeah, so that's exactly what you see here. Yeah, the bigger lambda is, the more you're gonna force your solution to be in one of these circles. The smaller lambda is, the more your solution is going to be here. Yeah. So if we make lambda large enough, we can make these weights W4 and B4, we can make them close to 0. We just have to make lambda large enough. Yeah. So that means that A5 equals the ReLU of A3. Yeah. So A5 equals the ReLU of A3, and remember ReLU looks like this. Yeah, so here we have ReLU Z, and here we have Z. So you see that the ReLU Z equals Z for positive Z. Yeah? So the ReLU A3 is either 0 when Z is negative, or is A3 itself. So that means in this case that A5 is roughly the same as A3. Yeah. So you have the identity function. Yeah. So you can have as many layers as you want, but if A3 is the input here, when the output, you're gonna also have something that is equal to A3. Yeah, and that is why ResNet works. So let's do some coding and see if we can improve the results of our small data set when we're gonna pre-train on ResNet 50. Yeah? So for our coding exercise, we're gonna use ResNet 50. So we will use a convolutional base of the first 50 layers of ResNet.